So this is limits of functions with exponentials. So we can kind of think of this as there's three different exponential functions. So if our b is between 0 and 1, that would mean that we have a proper fraction. Or our b could be 1, or our b could be greater than 1, which is not a proper fraction, right? We're bigger than 1, so that would include the 2's, the 3's, the 1.5's, e, anything bigger than 1. So it looks like this, basically. You have your proper fractions, and they make these shapes, just like this one does. And then you have your numbers bigger than 1, like 10, 4, 2, 1.5, and they make that's kind of exponential shape. So what's happening here is we have these two different situations for our limit. Obviously, if b is 1, it's 1. So if b is greater than 1, that's this one. So we'll put a little arrow here for that. Then you can see as x goes to infinity, our b goes off to infinity. And as x goes to negative infinity, our b to the x goes to 0. So b to the x goes to infinity when x goes to infinity, and it goes to 0, right, when x approaches negative infinity. Now, for this one, our proper fractions, that's this one, you can see as x approaches infinity, our b to the x is going to 0. And as x approaches negative infinity, our b to the x is going to infinity. So there are different ways to do these limits, but if you always bring it back to these, it's a quick, well, that one's infinity, that one's 0, that one's 0, and that one's infinity. So what we want to do is just use some tricks here to rewrite these. So let's try one. So right now we have 2 to the negative x. Well, we know with the negative, it's just going to flip and make our fraction. So as x approaches infinity, this would become 1 over 2 to the x minus 1. And so now we can look at it and go, okay, well, our b here, right, is 1/2. That's less than 1, so it's our second one. So we're going to infinity. That's this one. So that means this goes to 0. So it's going to look like this. If this was a half, it would decrease like that. See, just like there. There's our half. And you can see it's decreasing here. Okay, so that means this is going to 0. Minus 1. And so our limit is negative 1. All right, let's try another one. What do you do now if you have x to the negative 2? So what we wanted to do now is rewrite this. We have x to infinity and x, so we can change that to a t. So we want to rewrite it as limit as t approaches something, e to the t. So that means our t here is equal to 1 over x squared. So let's see what it's doing. So our x is approaching infinity. We already know that. So we already know that one is 0. Because it's our standard rule. This is a rational function, right? Denominator is bigger than the top. It's going to go to 0. Now, that's our t. So that means our t here is approaching 0. So now I can replace it with 0. It's the same number here, so 0. And now we go back and we look. We go, oh, well, that's infinity, infinity. See, we don't have to worry about it. If you look at these, when it approaches 0, it's approaching 1 on that one and that one. So it doesn't matter. It's going to be 1. So what it's basically saying is that we're getting e to the 0, which is 1. All right, how about this one? So this one involves a little bit of a trick. What we're going to do is we're going to divide them all. So we're going to basically multiply the top by e to the 2x and the bottom by 1 over e to the 2x. So where am I picking that from? They all have an e to the 2x in rational form and non-rational form. So if we go e to the 2x and we divide it by e to the 2x and we do that for all of them. That's supposed to be an e to the 2x on the top. They have to be the same. You can't just divide them by whatever you want. It's got to be a constant. Well, the same thing. All right, so now if we do some simplifying, we end up with the limit as x approaches infinity of 1 minus, and I'm going to bring that negative 2x down. So this would come down, and so 2x plus 2x. So we're ending up with 1 over e to the 4x. 1 minus 1 over e to the 4x. And then now we can rewrite it to use our rule that we have above. 1 minus, and then so I'm just going to take and go 1 over e to the 4 and bring the x out. 1 minus 1 over e to the 4, and bring the x out. So now we go back up and look. 1 over e to the 4, that's definitely less than 1. So it's going to be the second one, this one. And our limit is x approaches infinity, so it's this one right here. So if our b is less than 1, we're going to have this situation, and so we're approaching 0. So that means this one goes to 0, and this one goes to 0. So we end up with 1 on top, 1 on the bottom. If you want to get really picky, we can do that, and then it becomes 1. And all of these can be checked in the calculator. All right, what do we do here now? So you see x is approaching 0 from the right. So it's that same idea that we're going to do with the t. So we're going to rewrite this now as the limit as t approaches something, e to the t. Now with our rational functions, there's some tricks you want to use. So when you have a rational function and the exponent, you have 2 over x. We have this situation going on here. So if you're approaching 0, that's where we're going to get our vertical asymptote here. So it's either going to be going to infinity or negative infinity. Right? So if we have e to the 1 over x of 0 plus, then we got t to approaches infinity. That's this side, right? And then we end up with infinity for e to the t. So this is our rule from before. So these last parts, the limit as t approaches infinity of e to the t, and the limit as t approaches negative infinity e to the t, that's just up here. Okay. Because again, e is bigger than 1, so it's just those two. So infinity is infinity, negative infinity is 0. Infinity is infinity, negative infinity is 0. Okay, so now where do they come from? So if we have 1 over x, that's our graph here. If we're approaching 0 plus, that's from the right, you can see it goes off to infinity. And 0 minus, that's from the left, and you can see it goes off to negative infinity. So that means our 1 over x here is our t, so our t is approaching negative infinity. And our 1 over x, which is our t, and our t is approaching infinity. So we're going to do the same thing here. So we're going to take the limit as x approaches 0 plus of 2 over x. And then you can even look over here and see what they are, or use this. Remember, 2 here is just going to stretch it vertically. So if we're going from the right, it's going off to infinity. This means that our t is going to go off to infinity. And now we have rewritten it. So our t is a 2 over x. The 2 over x is going to infinity as x goes to 0 plus, which means our t goes to infinity. And now we can just use our rule. So limit of e to the t as t approaches infinity, infinity. Now, what if they get a little bit tricky and they say 2 minus and x minus 2? Well, this is just shifted. So if you remember our vertical asymptotes, this one's at 0 because that's our undefined value. This one would be at 2. And so what we need to do is just shift it back 2. So if that's at x minus 2 right there, and then if I shift it back 2, I can change that to a t or an x or whatever else I want and rewrite it. So this is really the limit. We still have to keep the minus because, again, we're approaching from the left, and so we need to approach from the left on the 0. But we're going to rewrite it, and I'm just going to leave it as x just because I'm going to rewrite it into a new problem that is basically the same thing, like that. And so this does the same thing. As we approach 2 from the left, we go to a negative infinity. And if I had a 5 over x, it would just approach 0 from the left. Now we do the same thing. Limit as x approaches 0 from the left of 5 over x. That's going to become negative infinity. So we would say that this is the limit as t approaches negative infinity, e to the t. And then that's 0. And there you go. So if it's shifted, you do the same thing with the 0. Just shift it back. And there you go. So there's your tricks. Now this one I didn't really mention, but this is just a negative 2x. So what I've done is if this one goes to infinity, well, that's our t. T is going to negative infinity. So it's another way of just getting it back to that e to the t if you have a quick one there. All right, I tried to show you everything that you'll run into. I guarantee I missed something though. So if you have questions, please ask.